we had so many cars that came with, let's say, a smart coil. And the car is making 3,000 horsepower, V8 twin turbo, 3,000 horsepower, beautiful, no misfire, everything fine. Then we feel that is a little behind power by our experience. But then you put a CDI, immediately drop exhaust temperature, and you pick up 500 horsepower.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Anderson from FuelTech USA. Now, FuelTech is one of those brands that's really made big strides in the last few years, and particularly if you're interested in cars at all and you've got a Facebook account, chances are that you've probably seen videos of various twin-turbo Pro Mod vehicles on FuelTech's own mainline Pro Hub dyno in the States, putting out around about 4,000 horsepower or some other insane number. FuelTech has in particular really made a name for itself in the professional drag racing scene, and that's also filtered down to street cars and maybe not quite such professional level drag racing as well. Anyway, it's interesting always to get an insight into what goes into developing a brand new ECU from the ground up, particularly when there are already so many quality brands with great reputations from countries all around the world. I was interested to find out from Anderson what spurred him into designing his own ECU, and as we'll find out, a lot of this comes down to some of the limitations with importation of products into Brazil. So it's one of those things where need kind of fuels a bit of innovation, and that's exactly the path that Anderson's gone down. We dive deep into some of the intricacies in this episode as well, with tuning methanol powered drag engines. There's some really interesting insights in there, particularly when it comes to differences between the likes of an inductive ignition system and a CDI or capacitive discharge ignition system. If you've got no idea what either of those terms mean, don't worry, because we're going to dive into that as well. But normally we expect that an engine will either have a misfire or it won't, but as we find out from Anderson, there's actually levels to this, and the spark duration between an inductive ignition system, which is quite long, and a CDI ignition system, which is very, very short but intense, actually can have a significant impact on the power the engine makes, as much as 500 plus horsepower. So that's not an insignificant amount. Anyway, huge amount of really, really high level information in here. It's great to lean on Anderson's knowledge at this level as well. I certainly learned a lot, and I'm sure a lot of you listening will as well. Before we jump into our interview with Anderson, for those who are new to the HPA Tuned In podcast, High Performance Academy is an online training school. We specialize in teaching people how to tune EFI, build performance engines, design and build wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD design, race driver education, data analysis, just to name a few. All of our courses are delivered via high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. As a podcast listener, you can also use the coupon code podcast75. That'll get you $75 off the purchase of your very first HPA course. I'll put a link to that coupon code in the show notes, and if you want to find all of our courses, you can find those at hpacademy.com/courses. Again, we'll put a link in the description. All right, let's get into our interview now. All right, Anderson, welcome to the podcast. Thanks for joining us today. And as we always do, let's get started by finding out a little bit about your background and how you got involved in the automotive scene.
Thank you, Andre, and it's a great pleasure to be part of this podcast. I think I'm a big fan of your job and your work on this industry, and I really appreciate the invite.
Oh, thanks.
So we're celebrating actually 20 years of FuelTech this month specifically. So pretty much 20 years ago, I was in Brazil. I started the company after a couple years already working on something for a college project degree, which was a very basic fuel injection. I may not even call as a fuel injection because it was just like a supplemental fuel injection controller, very simplistic controller for fuel only. At that time, that was like 1999, 2000 in Brazil. I would say Brazil was about 20 years behind the rest of the world, especially US, in terms of technology. Pretty much every single race car in Brazil, in drag racing at least, was carbureted. They didn't run standalone fuel injections, and they were pretty much limited to very old technology. Data logging, data acquisition was not existing. Laptops were not present on any kind of drag racing events. We had some kind of circuit racing that had some higher level cars, but nothing really on the majorly. It was very limited. No ECU was officially imported to Brazil at that time.
I'm interested, sort of, that's not that long ago in real terms, sort of around 99, 2000. There were a large number of options in terms of aftermarket ECUs worldwide. Strangely, a number of those seem to come out of Australia. With access to the internet and all of these brands out there, I would have thought or assumed that access to these products from Brazil would have been relatively straightforward. Was that just not the case, or were people not prepared to break the norm and try something that in Brazil was seemingly new at the time?
A lot of countries in South America, especially Brazil, Argentina, they are very protective with imported products. So pretty much you can average like almost 100% import taxes to bring something into the country. Then you also have like language barrier. Obviously, the language in Brazil is Portuguese, but then mostly no one was representing like another issue in Brazil officially. So you could not. It's not that you could import by yourself, but then you have to try to get tech support, try to learn by yourself. If you have any problems, you probably had to be sending that back to the manufacturer outside and sending back paying taxes again. So very few people really had standalone issues. And at that time, like you mentioned, Australia was leading far away with Motec, Haltech. I think, not sure Haltech, but I think Haltech was young yet, but Electromotive was one of the early ons. I remember seeing a few Electromotives in Brazil, but it was so rare that we could not even count on that.
I can understand the cost element with the import duties being 100%. I mean, essentially, you're going to be paying double for an ECU from outside of Brazil, even before you take into account that language barrier for tech support that you mentioned. On that note, I mean, I'm talking to you now and your English, obviously you're in the US right now, but your English is probably better than mine. I'm interested just in terms of the car scene in Brazil, how prevalent is the English language over there, or is it quite rare?
It's common more and more, but it's not something like, I'll guess like 20% of the people in car scene speaks English only. So it's a majority of the people really have a hard time to communicate. I live in US for a few years, but I still feel I cannot communicate well in English. It's a challenge, obviously, for the Latin community.
Let's just say that your English is better than my Portuguese. So I think you're doing pretty good.
Okay.
Okay, so I can sort of see where that drive to maybe fill this gap in the Brazilian market is coming from. Let's rewind a little bit though, because you mentioned that you were doing this as a college project. What are you doing at college? I mean, I'm guessing here there's something to do with electronics.
Yeah, I was doing electrical engineering in South Brazil, Porto Alegre. It was like a federal university. Basically, I had a few friends. They were into racing. I could not afford to have any. I didn't have a car when I had like 18, 19 years old. I was riding buses to go to school and that kind of stuff. It's in Brazil, it's not common to everyone to have a car. It's not really a transportation method everyone can afford. So I had friends that had some cars and a couple friends that actually have racing cars, which was more uncommon at all. And one of them he had a 1995 Chevrolet Vectra. It's a common car in Europe, in Brazil, and he removed the EFI and put a carburetor on because that was almost the only way you could modify to put a turbo on. And we were joking that, okay, now you're actually in electrical engineering at actually the first year, and you should be doing a EFI for us. And then I actually took the joke seriously, actually too serious. And I started designing something that I thought, okay, let me do this for a project college degree because I need to show something. I never thought this will become a product or a company. It was literally for friends and play with and have fun. At the same time, another interesting fact about Brazil specifically and South America. And that actually applies for different countries. The labor is such of a cheaper cost versus parts that everything that is a lot of people really spend more effort in the labor side of fabricating stuff than actually buying bolt-ons or things that are parts actually. So it's much cheaper in Brazil to manufacture our own part, almost to a point that your own electronics somehow, than actually trying to buy that something from another company, or especially if you have to import. At that time, I the project college degree was something I presented. I converted a car, actually a Volkswagen Passat, 4-cylinder from carburetor to EFI, and that was very successful in my university. I presented that, and really we're very excited about that. But I had plans to move to Europe at that time. I was offered a job or internship in Germany in actually some kind of motorsports, but I had to finish all the classes and I failed in 2 classes. So I was already promising all family and everyone that I would be moving to Germany and working on something cool. And at sudden I failed and I thought my life was over. I need to restart what I'm going to do. And pretty much I grabbed that product or that early stages issue, and I started going for some drag race events in Brazil. And I was like 19 years old. I stopped to every single pit or race car team and tried to show and sell for them. So pretty much only from, let's say, from a few hundreds that I presented the product, 4 of them actually opened their doors to test the product. And so next weeks I travel to their shops and I personally install it in their cars. And then actually I start building a relationship with them, which all of them I have a very strong relationship, and up to today, 20 years later.
Let's just pause there for a second and back up a bit, because there's a few things that I kind of want to dive into that you've just mentioned. I mean, first of all, you comment there about converting an EFI vehicle to carburetor to allow it to be turbocharged. It just is, seemingly so backwards given the technology that we've got available today. But I mean, necessity is the mother of invention. Of course, you do what you have to do. I'm interested with the development path of your ECU as it started out with this college project. Did you dive into looking at other systems and how they functioned, what they were doing, and get a feel for a development direction? Or was this a clean sheet of paper approach? And the reason I ask this question is that I always feel that looking at competitors' products needs to be treated carefully. It can end up basically putting your blinkers on or blinders on to sort of go down a particular path of development and ignore some other potential avenues. I mean, the flip side of this, of course, is seeing how other people do a certain task could also potentially save you weeks or months of development and software writing. So yeah, interested to get your take on that.
So yeah, I didn't have access to any ECU at that time.
And this still comes down to the importation costs. I mean, just getting an ECU to test out is obviously going to be horrendously expensive.
Yeah, and also there was another. Also, the laptops were not very common. I didn't even had a laptop at that time. It was like only a PC in the home. So first, I thought there was 2 Brazilian brands of ECU at that time, but one was based on knobs, like pretty much you adjust like knobs. I think it was based even on the older Japanese basic fuel controllers. There were only fuel controllers. So, and there was another brand, a Brazilian brand, which I never touched one, and I just saw racing, but I never really. To be honest, I felt bad about trying to reverse engineer anything. So I thought I was wrong if I would do that. So I completely ignored anything that existed at that time. But I had some limitations. So I had to do something that could not use a laptop because no one had a laptop on the racing track. So how could I try to teach them how to use a laptop in the early 2000s? It sounds crazy, but that was reality. Then I had only a 16 characters by 2 lines display and 4 push buttons, which was how I did the interface. So I could not do a 2D table or a 3D table because you cannot have like 32 by 32. It would be impossible to manipulate that. First is milliseconds, because I thought like load would be based on milliseconds, and I had basically no information where I found that, but let's say I was lucky on thinking about that. But then I was thinking, should I base my main fuel table in RPM or load? So I thought it would make more sense to be load, which was either TPS or map sensor. So I had a table pretty much 10 or 16 steps from vacuum to boost and milliseconds. And then I had a compensation table by RPM. And that compensation table ended up always representing the torque table, which would be like a 0% compensation in low RPM, then going to plus 15% at peak torque, and going to minus 10% at peak RPM, let's say this way. And that was successfully simple for the application in Brazil specifically, because the map generation, we built up a map generation feature that basically you would tell if your injectors were expected to be big for that setup, ride on, or small. If you have like saying, okay, this is a car that is going to run 29 pounds of boost, and I have ride-on injectors, it will pretty much put 10% to 100% linear boost table by milliseconds. And also we took in consideration the dead time, like typically a 1 millisecond dead time. And then you pretty much fill up that table. And then if you're telling that the engine max RPM is 8,000 RPM, we're just telling that, okay, at about 60% of that RPM, that's peak torque, put a plus 15, and the max RPM just put a minus 15%, and linearize that, interpolate that in between.
All right, let's just expand on this a little bit, because I'm going to pick that probably a few listeners maybe haven't experienced this style of tuning, because it is reasonably rare. But these days, the common technique, and I mean, FuelTech, you do offer this as well as an option, would be a full three-dimensional table for your fuel and your ignition, which that's what we as tuners have sort of come to expect. However, as you say, your limitations with your display here, your controller, that wasn't practical to have a 32 by 32 map. So instead, you're dealing with your fuel and also your ignition, which we'll get to, as two separate maps. You've got one that is your injector time versus manifold pressure, either boost or vacuum. So that's pretty straightforward, just again a 2D table. And then you've got this compensation table that overlays on the top of that versus RPM. Like you say, I mean, I think a lot of people lose this sort of subtle aspect, but really when we're talking about airflow into the engine, which obviously drives the fuel requirements, the airflow, if we look at a fixed boost pressure or load, for example, the airflow will represent essentially the torque curve on the dyno, and that's what you're saying there, that RPM compensation, if everything's working correctly, that RPM compensation should actually look pretty much like our torque curve. Now, again, to a lot of people, this would sound like a really simplistic way of tuning an engine. And I guess the question would be, does that RPM compensation actually work out to be the same at, let's say, 5 psi of positive boost and 30 psi of positive boost? Or is this basically, we're making some compromise there for the simplicity of that setup?
Oh yeah, absolutely. If you're replacing two 2D tables of 16 steps each, which only gives you 32 points versus a 32 by 32, which we're talking, you can do the math, but it's 1,000 plus cells. So it's 16 cells versus 1,000 something cells. You have to have some compromise. But I'll be honest, like for that time, it was more than enough for whatever even possible to diagnose it. At that time, we didn't even have access to wideband or two readers. So it was basically, okay, it's rich, misfiring, take some fuel off. I also remember Brazil, it's ethanol pump on pump since the 70s. So I didn't even play with gasoline since I moved into the US in performance world. So gasoline, it was completely outside of our range on performance. We always played ethanol or methanol.
Something that comes into that, because I see this come up quite a bit in tuning groups that I'm involved with, because ethanol obviously at the pump and as a race fuel has become the go-to for anything high performance, particularly if it's turbocharged. I mean, no doubt it's an amazing fuel. I think the part that kind of can get lost in translation there with these tuners that have grown up now only ever tuning on ethanol is it's a great fuel to prevent or significantly reduce the likelihood of detonation occurring. And I think there's now a generation of tuners coming through that have never really had the experience of tuning really carefully the ignition timing on a gasoline-based fuel to prevent knock. What's your take on that? Is this the new norm? Is this a problem? Or are we going to see more and more ethanol or alcohol-based fuel, so knock is going to become a thing of the past?
Like you said, it's a challenge because it's a completely different approach. Let me explain some of my vision between the difference between them, and maybe different from some theories. I believe it may be helpful for some people listening. A way of simplify the fuels is when you have gasoline only cares about air temperature. It doesn't even care about air fuel. If you have a good gasoline and a turbo car, you can run 0.90 lambda, you can run 0.85, you can run 0.80. If you have a strong ignition, you can even go 75, 70. It will burn and it will make okay power. Sure, obviously we'll lose power both ways, and if you have enough cold air, you are very safe on the ignition side. It's not going to be the air fuel affecting pre-ignition. So I almost don't see pre-ignition based on air fuel. Obviously, you make a little more sensitive to timing if you're running leaner, but at the same time is you really can, you are not going to pre-ignite the engine just by running lean if you have the right timing and cold air intake. But then when you move to methanol is absolutely the opposite. Methanol absolutely don't care about intake air temp. It actually even likes the hotter the air, the better the air fuel atomization and mixture, and no pre-ignition by temperature. But it is very sensitive to hot surface compressed ignition. So methanol, it becomes like a diesel engine very soon when you have enough temperature. If you actually put methanol and diesel, in my opinion, they are even closer. Methanol is closer to diesel than actually is to gasoline. Because methanol, if you really increase the surface temperature of something, typically the spark plug tip, if it becomes a glow plug, it will start the ignition by that. So basically methanol, you would be making the peak horsepower at the 0.80 lambda if you could run that in a turbo car. But the problem is if you're making enough horsepower to glow plug something or to increase temperature in something inside, you're probably going to suffer with hot surface ignition, which is the kind of pre-ignition on methanol. I mean, my experience, you always trying to run as lean as possible to prevent something to become a glow plug. That's kind of a methanol tuning. And almost timing is less relevant on methanol because even if you run, let's say an engine likes 20 degrees of time, you will make a certain boost. And if you add 25, you make 25, 28, you don't have anything becoming glow plug, it will not hurt the engine. You will just lose power. You will not pre-ignite, you will not do anything. You just lose power. So if you understand the principle of controlling temperature on methanol, you'll probably be safer.
I want to dive into what you've just said there and just get some clarification around a couple of terms. We've used the term detonation and you've used the term pre-ignition. I just want to make sure we're speaking the same language and be clear for our listeners that those are two very different forms of abnormal combustion. We've actually discussed this in a bit more detail in a previous episode on the podcast, which we'll link to for people so I don't have to go too deep into here. But essentially, detonation occurs after the spark event has already begun the combustion process and is driven, as you were saying, it's heat based. So if the combustion temperature in the combustion chamber becomes too great, we get pockets of unburned fuel and air spontaneously combusting. So that's knock or detonation. Pre-ignition, as its name it would imply, is a type of abnormal combustion that occurs before the spark event. It's actually much more damaging to the engine. And that's as a result, as you're mentioning there, of hot spots. So I just wanted to get that clarification. I'd 100% agree with you on a gasoline-based fuel. Intake air temperature is super, super relevant to the engine's likelihood of suffering from knock. I would argue, though, that the air-fuel ratio does impact on this because what we're looking at is charge temperature. And as we go, let's say a typical air-fuel ratio or lambda for a gasoline turbocharged engine, we might be targeting, let's say, 0.78, 0.80, just to chuck a number out there. As we go leaner, so let's say 0.90, which I think you threw out there, yeah, absolutely, the engine will run there. But what we see is as we lean the air-fuel ratio out towards stoic, we start to see the combustion temperature climb, which again is another thing that will help drive the likelihood of NOx. So that's the caution there. When we get onto alcohol-based fuels, these are a very different type of fuel, and while they are much, much less likely to suffer from detonation, the bit that's easily overlooked is they're actually more susceptible to pre-ignition than gasoline-based fuels. So it's kind of a different level of care and consideration that comes with these. My take on this, and at this stage, you're almost undoubtedly got a hell of a lot more experience than I have, but tuning on methanol-based fuels for drag applications, I sort of find, actually, let's go a little bit deeper. Let's take gasoline for a start. The air fuel ratio that I chucked out before, 0.78 to 0.80, maybe 0.85, we're going to see peak power at 20 pound of boost, maybe around about 0.85 lambda, give or take. You're going to want to test and find out. If we go richer, we're going to start to see the power fall off a cliff, particularly once we get to sort of maybe 0.75 and richer. If we can still ignite that rich air fuel charge, we're going to see the power start to fall off a cliff. Likewise, if we start to lean the air fuel ratio out, once we go past maybe 0.95, we'll start to again see it fall off a cliff. On methanol fuel, at least my experience has been that you don't tend to see that significant drop off in power as we move richer, and richer on methanol fuel is certainly tends to be safe. You don't kind of get that additional power by chasing that ragged lean edge like you do with gasoline-based fuels. But the flip side of that as well is when you're chasing that lean, ragged edge on methanol-based fuels, things can go pear-shaped very, very quickly and destroy an engine. So do you sort of, is my experience match yours in terms of that side of things?
I think what we've been experiencing later, or I would even separate the methanol in, let's say, a mid-power methanol versus an extreme power horsepower methanol. So the mid-power, I'll throw some numbers. They may not be very accurate, but they may just be as an example. Let's say you have a 4-cylinder, 30 pounds of boost methanol engine. If you run them at 75 lambda, it's probably okay. It's probably never going to hurt. It's not enough heat to become a glow plug, the spark plug typically. But then if you run from 75 lambda to 70 lambda, you're probably going to see 5% power increase or less. Like you say, this is very relevant. The dip is not that big, so why not run 70 lambda? And if you need, you just add 2 more pounds and you're safe. That's good.
I think that kind of matches my learning curve when I switched to methanol, and I started trying to apply a gasoline-based tuning approach where, the old story, lean is mean, and, quickly found that actually wasn't the way, and we've got this flat relationship between power and lambda target with methanol compared to gasoline. And then I sort of switched my tuning strategy more towards what you're talking about here, where because we don't see that fall off in power, well, a richer mixture is undoubtedly going to be safer. The difficulty, and we're getting a little off track here, so for those listening, we're going to come back full circle here, but this is a really interesting conversation, so we'll see it through to its completion. The limitation generally in terms of how rich we can run on methanol fuel is really around the capability of the ignition system and its ability to light off a very rich air fuel ratio. So once we start getting into the 0.65 lambda or thereabouts, maybe richer, you need a hell of an ignition system to light it off. So you might not be actually seeing a degradation in your power because of the air fuel ratio you're running, but the ignition system just simply can't light it. So you're not making any power if you're misfiring. Again, that match your experience?
Yeah, and then going for an extreme horsepower methanol engine. Let's use a 4-cylinder, let's say a 80 psi 4-cylinder turbo engine. If you try to run 75 lambda on this engine, you are going to make enough heat into the spark plug that typically the spark plug will become glow plug in a drag race car in the first 330 like. And then once it becomes glow plug, you lost the engine because detonation and will definitely hurt the engine immediately. Then you try to go a little richer. So you go 70 lambda, then you don't hurt the engine at 330, but you hurt the engine at 660. Then you try to go 68 lambda, 67 lambda, 66 lambda. But then, like you mentioned before, you have the ignition problems eventually. And that is where a CDI versus a inductive ignition makes a huge difference. because it's not about how much energy you throw during 50 degrees of timing. It's how much energy you can throw in the first 2 degrees to immediately break that specific, or you can actually fire the mixture right away. Because if you're actually having a very long duration spark on a methanol engine, you're 50 degrees behind already. You should be doing all that energy on the first couple degrees. So that's why concentrating the spark on the first, that's why having like a peak 200 amps on the primer of the coil versus 12 amps makes a lot of difference. If you have a strong ignition, you can actually go richer on that aspect. But then the methanol, when you have that amount of boost plus strong ignition, you have a partial misfire. And that partial misfire is not very well identified. You just have a partial combustion of the whatever is inside of a combustion chamber. And that partial combustion will actually show in a severe loss of horsepower. So we experienced on our hub dyno, like a 4-cylinder car, just by running from 66 lambda to 70 lambda, 300 horsepower increase. Because you could not even figure you were misfiring. Another test we done, it was interesting, was 2019 Maryland import versus domestic. Carlos Daoud, Kaká Daoud, our business partner at FuelTech, he had a 4-cylinder over there, the Cobalt with the Opel engine, the C20XC. And the car has a 88 millimeter turbo, 87 pounds of boost. He was actually 20 miles per hour slower than anyone else, or not anyone else, but the faster cars. And he was running 66 lambda, 87 pounds of boost. The spark plug were looking, it could not pull any fuel out. It was like, it was already having hit until the second thread or something like that on all spark plugs. It was even the engine, it was everything fine. But then we realized, man, we need to pull fuel out, but we cannot have this becoming a glow plug. So we realized, let's replace the spark plugs, the 9 by 11s. So we put 11s, made a pull without any change on the fuel map. The car came back, same mile per hour. We looked at the spark plug were brand new. So we actually pulled it like from 66 lambda to 69 lambda. The car made 5 miles per hour more, came back from the run, look at the spark plugs, they start getting some heat. Then we pull a little more, 70 lambda, 3-4 miles per hour more. The spark plug became, okay, that's it. We cannot go too much farther. Then we tried, okay, let's use a recessed spark plug, or even use some washers below the spark plug and pull the electrode from the inside of the combustion chamber. And even use the O2 sensor, the paste that actually increases conductivity between the threads or help just the thread. We even add that. But by recessing the plug, we kept the same air fuel, same amount of fuel. The car made same horsepower, but the plug come back colder again.
So you could go leaner again.
We went leaner again. Then another 5 miles per hour. Next run, we reversed the water from the intercooler. He was using intercooler to actually go first on the head before the intercooler. So, and then we spent 2-3 bags of ice before the run to have the head literally very, very, very cold. So then the run was back, the spark plugs were back to cold again. We pulled another 5% or 3%. The car gained another 3-4 miles per hour. And the spark plugs were like, okay, hit enough. But if we change one spark plug from 11 to 9, or if we don't use the spacer, or if we don't run the water like that, it will hurt the engine in first run. But then it just came to, okay, you should still try to run as lean as possible to gain any extra horsepower, especially on this level. We could not run any more boost pretty much with that size turbo. So you had to run on the leaner side, but at the same time, you need to prevent the combustion chamber to become a glow plug.
Absolutely. All right, some really interesting insight that you've given there, and it's worth spending a moment just going a little deeper. So essentially, when you're at this extreme power level, I guess we could consider that spark plug to be the canary in the mine shaft. That's what you're looking at as an early sign that things are starting to go pear-shaped. And I think this is an element that's become lost with the current generation of tuners, maybe outside of the extremes of drag racing. In the older days, when we didn't have access to wideband air fuel ratio meters, reading spark plugs was the norm, and I think it's becoming a lost art. I wouldn't say that I'm a pro at it, but I mean, with our drag cars, I would always pull plugs after a run and inspect them. It's amazing what you can tell. In terms of the heat range of the spark plug, so this is in and of itself, we could probably have a full podcast just on spark plugs and heat ranges is actually quite a complex topic. But with what you're saying there, the heat range of the spark plug, what we're essentially doing is trying to choose a heat range so that we can get rid of the heat that the spark plug is exposed to so it doesn't melt and become, as you mentioned, a glow plug. What's the downsides then of just choosing the coldest heat range plug that we can get our hands on?
For a racing engine, a methanol engine, it will be emissions or it will be related to not even cold start, because it's, in my opinion, there is no downside. I would never run something that is not the coldest plug on a methanol engine, unless, like I said, in a racing engine, right? I'm talking racing. So you want the coldest possible. The only reason why not to be as cold if your engine is not well designed or you have a failure on the head design, especially in the combustion chamber. Let's say you have a corner of the combustion chamber that is sharp, and that will become your glow plug before the spark plug. Then your spark plug still looking brand new because you're using 11s and everything is fine, but your corner of the combustion chamber is becoming glow plug. And
so you've still got a hole through the center of your piston anyway.
Yes. That's even why a top fuel engine or a nitromethane engine, they design the engine to actually have a controlled hot surface area that will become a glow plug before something. And that can be even a spark plug or sometimes can be even an insert on the combustion chamber that will purposely become a glow plug. Then we go another podcast because then you're talking nitromethane, you're talking a fuel that likes 70 degrees of timing, and the detonation will actually happen that degree. So it's a perfect word, but methanol hates 70 degrees of timing when the detonation happens.
Okay, we won't get into the world of nitromethane on this particular episode. Before we move on though, just in terms of, you mentioned essentially what you're looking at on the spark plug in terms of deciding whether it's running too hot or too cold. Now, I know we don't have the benefit, unfortunately, on a podcast of photos or a visual cue, but is it possible for you to describe what someone should be looking at on that spark plug to decide when they've got their heat range correct?
Yeah, I mean, on a methanol extreme engine, it doesn't matter if it's a 4-cylinder, a 6 or a V8, you look from the crown, you should see it all burned, you should see it all cooked, become like, cannot have any chrome on the top, and you have to have 100% of the top of the spark plug already turned from chrome to some satin gray. Then you want to see that extension typically to the second thread of the spark plug. That's usually, I've seen people, some extreme cases, going a little more to the third, fourth thread, but that's very unlikely to be successful. At the same time, if you still see some chrome on the top, you're still rich, at least for that condition.
So this is, you're talking about I believe it's a chromium plating on the threads plus the earth strap. So we're looking for the discoloration as that chromium, if I'm correct, I'm not a metallurgist here, but that plating on the ground strap and then the threads, that burns off with the heat?
No, it's not even on the ground strap, it's actually on the actual base already. You know what I mean? The ground strap, you can see a gold mark. It's more about timing. We want to see the gold mark almost probably on the 90-degree bend, but that's more about timing. But feel is about how far the heat actually turned the gold. Imagine if you were a child and you got your mom's knife from the kitchen and you go on the fire, you turn it into red, your knife. You know, when you look how far the red come after the knife become cold back on, your mom's still going to see you did that. There's no way you can hide that. So that's what we're looking for. In reality, the spark plug becomes red inside of the combustion chamber, but you want to control how red it will be. Because if it goes too red, then it will be causing the hot surface ignition.
And essentially what we're looking at is the signs that are remaining, as you mentioned with the knife analogy there, on the spark plug after it's come back from a pass. We obviously don't get the benefit of actually seeing what's going on inside the combustion chamber. I will just clear up as well. You mentioned that for these methanol drag engines, really there is no sort of condition of too cold, which I'd absolutely agree with. I mean, I guess the only caveat I'll add for that is for a street car running on pump gas, That's not the case clearly, and if we go too cold, what we're going to end up with is over time basically deposits will build up on the spark plug. The spark plug's not actually running hot enough to burn those off and remove them and stay clean, and over a period of time we're going to end up with the spark plug fouled and the car won't start. So two very different ends of the spectrum there, and the other benefit we've got with methanol is it's a very clean burning fuel, so you don't get the carbon deposits that we tend to see on gasoline. Again, just on this CDI versus inductive ignition, when I was drag racing my old Evo, we didn't really have good inductive ignition systems. The coils that we have available now, like the popular IGN 1A coils, just they weren't a thing. I kind of gravitated towards the M&W ProDrag CDI and the Mercury outboard CDI coils, which are still a popular option. In terms of the modern coils, like the likes of the IGM-1A, where's the limitation on those, or does this become the spark duration problem that you mentioned, as opposed to the outright energy to actually light off the spark, or the combustion charge?
So first thing is important to understand the difference between the CDI and the inductive for the audience. Is the inductive, it generally even if they both have, let's say, 200 millijoules of spark energy. The spark energy is the area of the discharge of the amps, or let's say of the current being discharged through the spark plug versus the time. So you can actually discharge 200 millijoules over, let's say, 5 milliseconds, or you can discharge 200 millijoules over 0.2 milliseconds. And that's a realistic difference between those. A CDI, it stores all that energy in a capacitor, and the coil is just a transformer, a voltage transformer. So the energy is not stored in the coil. So you just use the CDI coil to pretty much transfer it from the capacitor to the spark plug through a transformer. So typically a spark discharge on a CDI is about 0.3 milliseconds, like 300 microseconds.
So you're getting all of that energy out almost instantly, as opposed to over an extended period of time with an inductive.
Correct. Yeah. So there are some applications like, say, low RPM, where 200 microseconds idling, it's a tenth of a degree. So you are such of a quick discharge that sometimes, depending on the air-fuel mixture and the atomization, you don't hit properly the cloud of fuel properly, or it's so slow. That's why even MSD, multiple spark discharge strategy, became in the past, where they fire like 7 times idling as MSD to compensate some of that duration lack of CDI, a typical CDI. Lately, the modern CDIs, they can actually discharge so much energy that even one discharge is enough to start ignition even at low RPM and low load. I mean, in my opinion, if you do a comparison, an engine running, let's say, 0.90 lambda, no matter the fuel, 0.90 lambda at a low RPM, a smart coil will actually make a better combustion, because it will expose the combustion chamber for a longer period to actually light up that properly, even if the mixture is not very well atomized. Or imagine if you have clouds of fuel separately. So sometimes you need to have a longer exposure to a spark to really hit all the clouds.
So this comes down to mixture preparation, essentially, which is a little bit beyond our scope of EFI, but it is something. I mean, it's easy to assume that we have a nice homogeneous or thoroughly even, well-mixed air-fuel ratio inside of the combustion chamber, but that obviously isn't always the case. So when you don't have good mixture preparation and you've got sort of lean areas and then rich areas inside of the combustion chamber, that's when you can get yourself into trouble. So, I mean, to paraphrase here, it sounds like what you're saying is that a CDI ignition system, excellent for a methanol high output drag engine, because we've got that very rich mixture under high boost levels, wide open throttle, then you're going to get a guaranteed burn. But potentially under idle cruise conditions, leaner air fuel ratios, maybe if we're talking about a street application, that very short duration spark with a CDI could be problematic. Is that sort of, am I picking that up correctly?
Yeah, I will surprise you in a few about the gasoline high horsepower nitrous engines, but let's come back to But you're right. For a mid load and low load and the emissions, or idle any engine that you really care about that, the inductive ignition is better. It will generate better fuel economy, even better eventually horsepower. But there is a transition where you actually are at high RPM, you have too much fuel, you start already fighting to start the spark inside of the combustion chamber when you have a extreme compression of air fuel. So that's where the CDI will be a lot more capable of starting the arc and not misfiring, because like as a comparison, let's say our 750 millijoules ignition box, it will throw 175 amps on the primary of the coil versus a 12 amp on a smart, or a 15 amp on a smart coil. So it's 10 times higher, 10 times more energy in the first degrees. And that is also reflecting on a more effective real timing, because you may be firing at 20 degrees, but if you're not being successful in the first few degrees and you're still doing a very long duration, you may actually fire later, but then you're already 5-10 degrees late or on that event.
That was actually going to be my next question. All other things being equal, if we switch between an inductive ignition system and a CDI ignition system at these higher boost levels, but let's say at a point where the inductive system is still capable of reliably lighting off the fuel air charge, just on the basis of the spark duration, does this almost have the effect of, all other things being equal, affecting the effective timing of where the fuel air charge actually starts burning?
Oh yeah, I'll tell you something. We have a hub dyno at FuelTech, let's say, and that dyno operates every weekday for the last 3 years, 4 years almost. We had so many cars that came with, let's say, a smart coil, and the car is making 3,000 horsepower, V8 twin turbo, 3,000 horsepower, beautiful, no misfire, no, everything fine. Then we feel that is a little behind power by our experience. And sometimes we even have a quick switch CDI kit over there. And we did and that happened like dozens of times. Then we changed it to a CDI ignition, and that car picks up like 500 horsepower. And then you say, how is that possible? Obviously, it was already misfiring, but not a misfire. Misfire is a wrong term. Maybe it was already late firing.
Yes. So effectively retarded ignition timing, but you don't know about it.
Yes. It was late firing randomly and not repeatedly. So you see an average EGT, exhaust temperature, higher, but not really consistent. The EGTs were not really flat. It was like something is weird, but you cannot hear a misfire. The engine runs good. It was okay. But then you put a CDI, immediately drop exhaust temperature, and you pick up 500 horsepower. And that happens like many times. But again, unless you test this stuff with your own eyes, you say I'm lying. You know what I mean?
I mean, it must be a hell of an effective way of selling CDI ignition boxes.
Yeah, and then the effective timing is one thing is hard to understand until you really understand. You have something like that. So, but again, we may be talking to extreme application. Let me tell you something more that I think we changed the story about drag racing in the last few years. 5 years ago, tuning a nitrous engine on, let's say, a Pro Mode nitrous engine was running 0.80 lambda until you hurt the engine. You add nitrous until you hurt the engine. Then you make 2 runs, you change pistons. You make 4 runs, you change pistons, and then you run again. And that's it. And everybody was, oh yeah, gasoline doesn't need a strong ignition. Let's run just a regular distributor with a regular ignition, and that's fine. Then we start testing so much, and we figure, man, one day we try like, okay, instead of running 0.80 lambda, let's run 75 lambda. Okay, but then it reach misfire with that ignition and pops the intake. And a lot of people will just back off into 0.80 lambda because the reach misfire scared them off and hurt the engine. What we did, we put a stronger ignition, and then it did not misfire anymore with 75 lambda. It lost some horsepower. Then we added more nitrous. Then we made more power than before. Then we said, okay, what if we run 70 lambda instead of 75? And it lost horsepower, did not misfire. We add more nitrous. Then, to have an idea, my business partner, Luis de Leon, he's racing Pro Mode, and he has a nitrous car. That car makes 2,100 horsepower naturally aspirated on the hub dyno. and we spray about 4,000 horsepower of nitros worth in top of that. But it doesn't make obviously that much. It's not efficient, but it goes way above 3,000 horsepower, wheel horsepower, 3,500 wheel horsepower on night with all the nitros. But it has to run 0.60 lambda, 0.58 lambda to survive. But it does survive. So in the end, it's like faster, quicker, and reliable. Now, these nitro engines with strong ignition, richer, and a lot double the nitros than before are more reliable. They can run a whole weekend without changing pistons.
Yeah, okay. I mean, that's a really interesting example of how approaching every tuning job with the same expectations in mind really can end up limiting your outcomes, as opposed to, as you've done, going and testing and sort of asking those questions. Well, what if we do this? What if we go richer? What are the downsides? What are the upsides? And actually experimenting. But again, it also comes down to the limitations that the ignition system really drive a lot of these decisions we make around what air fuel ratio we can physically run, because obviously if we don't have an ignition system capable and the engine's rich misfiring, well, that becomes the rich limit. We can't go any further.
And just now the limitation is how much nitros you can actually spray without coming back from the intake from the throttle bodies.
I just want to interrupt our interview with Anderson for a moment here and talk about a package deal that I know you're going to love if you're enjoying this chat, and that is our EFI Tuning Starter Package. As a special offer, you can use the coupon code FuelTech100. That will get you $100 off the purchase of our Tuning Starter Package. That starter package includes our EFI Tuning Fundamentals course. As its name implies, this will teach you the fundamentals of EFI tuning, how the engine works, how the ECU works, what we're trying to do when we're optimizing fuel, what we're trying to do when we're optimizing ignition timing. This is not specific to a particular engine. These principles remain the same regardless what engine you're tuning, regardless whether it's naturally aspirated or forced induction. This package also includes our Understanding Air Fuel Ratio course, and in my experience, this is probably one of the most misunderstood topics in the world of EFI tuning. We'll teach you what air fuel ratio means, what we're trying to do when we're optimizing the air fuel ratio. We'll also give you some safe starting air fuel ratio targets for a range of different engines so you can get your engine up and running safely without risk of damage. Then, most importantly, we'll show you how to test and find the optimal air fuel ratio for your engine combination and your use. Then we jump into our practical courses, and you can choose between our practical reflash tuning course, perfect for those of you who want to learn how to reflash factory fitted ECUs, or you can choose our practical standalone tuning course, of course perfect for those of you tuning aftermarket standalones like the FuelTech that we're talking about in today's podcast episode. Both of these courses are generic, so it doesn't really matter what type of ECU you're tuning or what sort of engine you're tuning. Both include a step-by-step process you can apply to your own tuning. And this breaks down the entire job. I know it can be a little daunting when you're fresh to tuning, you haven't got a lot of experience. It can be hard to know what to do first and what order to progress in. By applying our step-by-step process, this makes the job really easy, and each of the individual steps is quick and easy to complete. In no time you've got to the end, you've got a completely tuned engine delivering great power, great torque, and most importantly, great reliability. Going through it in this process also means you're not going to overlook any critical steps that could waste time, waste money, or even potentially damage your expensive engine. Again, up to this point, both of the practical courses are generic. From here, both courses also include a library of worked examples, and this is where we go through an informal process of applying our step-by-step tuning process on a specific engine and a specific tuning platform, and this will give you experience on a wide range of different platforms. So again, that coupon code FuelTech100, it'll get you $100 off the purchase. And remember, all of our courses come with a 60-day, no questions asked money back guarantee. So if you purchase and for any reason at all decide it's just not quite right for you, no problem. Flick us a message and we'll give you a full refund. Let's get back to our interview now. All right, I feel like we've gone down a very interesting path, but we've missed out on a hell of a lot. So what I want to do is just sort of come full circle and let's get back into the development of FuelTech. As we left it, you've sort of got this university/college project that you've convinced a few race teams in Brazil to trial out. obviously it's developed a hell of a long way since then in the 20 odd years that have gone past. So can you give us maybe the sort of fast track sort of development path? How did you go from there to what FuelTech is today?
Sure. So that was, like I mentioned, early 2000s. We had almost only carburetors in Brazil. My college project degree, just became a startup company. I was manufacturing pretty much by myself in my bedroom apartment. I was traveling to some racetracks until we start feeling, man, we have something that people may be interested on that. So it took us 3-4 years to really establish like an office, having a few employees assembling stuff and thinking a little forward, like how to develop that product. Then we start controlling ignition, then we start controlling a little more stuff, and then that became at the first of ECU itself. We started really controlling fuel only, then ignition, and then more stuff. Then we figured out the demands. Okay, we need to read a wideband O2 sensor, so we did the first wideband O2 reader, then data logging, but we still were behind, 20 years behind the rest of the industry, I would say. But in 2007, it was the first time I went to US as a spectator to NHRA Sport Compact race in Englishtown. And it was interesting because I still felt like a young kid looking for the racers. I came early, like a Thursday early morning, and we were sitting on the outside of the gates because the gates were still closed and it was cold. And a few race teams actually invited me and my friends to come inside, and then we started meeting them. And we were happy or lucky enough that those guys were like Gary Kubo and also Perry from Red Bull Racing Gardella team, the tuner, and they start showing to us how they were doing at that time. And basically, the biggest difference they were doing is like the time-based rev limiter, which was their type of traction control from the 2007 year. When we came back to Brazil, we thought, oh, man, we need to do that because the Brazilian racetracks were terrible. We were like just asphalt. At that time, was no glue, no prep, nothing. And most of the 90% of the cars in Brazil were front-wheel drive. So we implemented that software update and rolled that out. And the first race, every single car dropped like 1 second and a quarter mile. And that was the biggest leap in Brazilian drag racing at that time. And that got us up, excited to travel more, to go more to US, understand what the other and the technology was being done. So in 2008, I started the company. I really thought I could reach the US market. So 2008, we started FuelTech in California, FuelTech USA. And I knocked like over 300 doors of shops trying to show the product and that. And then only one shop actually opened the door, was Jack Sakiti. He was actually a Volkswagen air-cooled guy trying to build a front-wheel drive Honda. And we installed it on that car. But that car never actually went to racing. So we ended up spending a few years trying to reach some of the market. But we realized that we were not ready for the market yet. Our product was still a lot behind. So a lot of people don't even, still today, I mean, we're a younger company. We're just 20 years old now, competing with companies that are 30, 40 years old. But at 10 years ago, 12 years ago, we were only 5, 6 years old. So we're a younger company.
I guess what you've seen, though, is a sort of an exponential increase in the capability of your product. You've had to basically play catch up and do that very fast to have a product that's competitive. It's just talking a little bit more about breaking into that US market. You've got these teams that are established, they're getting results, maybe they're winning, they've got their ECU brand of choice that they're running, they know it inside and out, and it's getting the job done for better or worse. It must be incredibly hard to convince someone to throw away what they've been using for the last 5+ years or whatever it may be and go with something that, let's be honest, at this point in time is probably relatively unknown and in their eyes completely unproven. How did you break through those barriers?
So in 2008, we tried California, it did not work. Then we tried, okay, let's do PRI show. So we have 2009, 10, 11, and 12, a PRI show booth, a 10 by 10 foot with some Walmart tables and product on the top of the shelf. And almost nobody stopped by, and we had almost nobody really paying attention. Everyone was saying, oh, you guys doing this wrong. It should be something without a screen, under the dash, and it should be doing different. Nobody wants a screen. It was that feeling we had. But then in 2012 or 11, 12, we started getting some traction on the import after many tentatives in the Orlando area or Florida, some of the imports started using our product. It was at that time, it was that the import racing, I was going to say a lot of the ECUs over there were were simpler models. Were not as advanced as circuit racing or other forms of racing. And that kind of was a little easier for us since we're a simpler ECU. And a lot of these tuners were not very used to a lot of advanced technologies. So we started getting some traction. But what really changed our path into the US was Proline racing. I had a friend, a Brazilian racer, that was buying 2 Pro modes to take to Brazil. And he called me and say, "Hey, I'm buying these 2 Pro modes from a company called Proline Racing. I want to use FuelTech on those in Brazil because I've been using our system forever and I don't want to use whatever they have because this is being local." So I pretty much called Eric Dillard from Proline Racing. And it was 2012 and introduced what we had at that time, which was the FT400 ECU. But then I knew we were not capable at that time to replace whatever they were using because we could not even do sequential fuel injection. We could not even do individual fuel trim. We could not even do a tool correction. We had so many limitations. We were still a lot behind. But then that conversation was really good because I understood what they needed. And at that time, 2012, we were already redesigning our FT500 new platform, the ECU, the Power FT ECU. So we actually were able to shift our project to actually get what had to be done so they could use the FuelTech or our ECU on those cars. But I told my friend, "Hey, just buy with the ECU they were using, which was the Big Stuff 3. And then they are comfortable with that. And give me a couple of years, we will have something that we can run on your engine."
So is a lot of the development at that point, has that kind of been driven by what Proline had told you and their requirements to run their Pro Mod engines reliably?
Yeah, so basically what we understood clearly what an engine like that was demanding, like in terms of control, like 16 injector, individual fuel trims, and a lot of stuff was common today, but it was not common 10 years ago. Very few ECUs could actually do those kind of features. So we understood that clearly, and we actually designed the FT500 to accomplish that. And then when they delivered the cars in Brazil, they pretty much, Steve Petty, one of the most recognized tuners in the world, turbo cars and supercharger cars, he went to Brazil to tune those cars they were delivering. And then he came to a few races and a couple races, and they saw from the, let's say, 200 cars racing, 195 were using FuelTech. So that actually, yeah, we had that kind of market share in South America, and it's very impressive. And this is another thing, in South America, no matter the type of racing, we are probably the number one everywhere. But in US, obviously, because where we showed up was drag racing, a lot of people obviously relate us to a drag racing ECU.
Yeah, I'm interested to talk about that in a little more detail because you're absolutely right. I mean, I think most people on this side of the world or outside of South America probably exposed to the FuelTech brand have probably kind of pigeonholed it as a drag racing ECU. And I mean, there is a lot of truth in that. You've obviously had a lot of success in drag racing, and a lot of the feature set, which hopefully we can dive into in a bit, is driven around drag racing specific functionality. I think, and this might be somewhat controversial, maybe you'll disagree with me, but my own stance on this has always been that running a 3,000 plus horsepower engine at maybe 10,000 RPM, maybe 50, 60, 80 pound of boost and 100% throttle, it might sound stupid, but I see that as a relatively straightforward task. Now, I mean, obviously there's levels to this, but let me go on. In comparison to a street-driven car, where what we're concerned about is good cold start performance, good hot start performance in a wide variety of different ambient temperatures, idle speed control across everything I've just talked about, good transient response. I think, and I know this from a tuning standpoint, getting all of that stuff really, really perfect, as good as we can to replicate an OE factory car off the showroom floor. That is much more complex and time consuming and intensive on the ECU than running that 3,000 plus horsepower car for 5-6 seconds down a drag strip. So on that note, what was your sort of development process around bringing in these other elements, or were you already doing that but it just was lesser known because of your sort of exposure in drag racing?
Exactly. We always been very advanced on that. Actually, the South American market, obviously, there is more street cars than they're racing, and all the controls like electronic throttle control, idle control, boost controlling, or even transient or startup, tune-up. All of that is something we have a very advanced in our understanding. But like you mentioned, we were labeled by the success on the drag racing that probably we didn't have that of. But I'll tell you something is if somebody hasn't used our system in the last year, it's going to probably be surprised with our latest software. Such of a complex, not complex, but advanced features and controls we have. I'm not sure, but I believe we were maybe one of the first to be controlling like electronic wastegates. Our two correction, it's one of recognized one of the fastest and most reliable ones in the industry. So there's a lot of that we do, and especially circuit racing in South America were very popular. It was the last class we succeed because it took us to be successful in US to be recognized back home, if you understand me. Before that, everyone was, and I will tell you, we took the circuit racing success when we released our active traction control, and so this is what made us succeed a lot on the circuit racing in Brazil because we developed such of a successful traction control, active traction control based on four-wheel speed and a lot of strategies on that. That we just the cars that had FuelTech, they were just a couple seconds faster than any other car. Then everyone else switched. So that's kind of the advanced we done, and it's hard to promote everything because it's something that's so niche.
I think that's a really good feature to just talk about briefly because I think there's a real disconnect between an advertised feature set that an ECU manufacturer promotes on their website or on their marketing information, and I think something like traction control is seen as like a tick box. Yep, we've got that. From my perspective, having actually been deep in the weeds with a whole bunch of these different ECU platforms over a couple of decades now, I mean, I have experienced traction control on, I don't know, maybe 6 or 8 different platforms. And I would say that 9 out of 10 times it doesn't, like it might stop the car from wheel spinning. So tick on that box, yep, okay, we got traction back. But the car that was beside you just blasted off into the distance because it was overbearing and really didn't do the job properly. So, I mean, there's traction control from my perspective, and then there's actual traction control that is effective and makes the car faster. How do you, what did you sort of see at that point set your traction control strategy apart from the competition?
So let's say one thing we realized is you need to actuate really fast, right? And you need to keep the engine under balance. So what we have a strategy of how we reduce power, and the one thing is we do a ignition timing per cylinder with a randomizer per cylinder, but instead of pulling 5 degrees of all cylinders, we pull 20 of few of them, and if we need to pull more power, we pull that same 20 degrees from more cylinders, and then we bounce the other ones back with no retard, and that keeps the engine under certain tension that instead of like just stopping the engine and you, like you mentioned, you stop spinning, then you come back spinning, and that keeps the engine. You can really, right now, if you set up, I want a 7% wheel slip. With that strategy, in addition with a slightly ignition cut, we can actually keep a perfect 7% slip on the engine. So instead of just from 7 dropping to 0 and back to 8, and like you mentioned, so that's where I believe we actually succeeded more. Then obviously you add very fast processing, then you also use PID control where you can predict what's going on. So if you're actually hitting the 7% in a ramp that is going to crazy going above 7, you need to obviously start acting before. If you're slowly hitting the 7% slip, you can be less aggressive on that. So the setup on that, combined with our experience, like say on drag racing, I believe which was what made the most successful strategies on that specific matter.
I'm interested in your stance on how you balance out the complexity and effectiveness of a function like traction control, because you just mentioned PID control algorithms, which I know are notoriously difficult for the majority of tuners to A, get their head around, and B, actually set up properly. And the problem is that when you make these complex functions that require a lot of input from the tuner, it's easy to get yourself so far away from the ballpark that you just can't see your way back. And you may not even know that you've got it that far wrong. So the question I'm getting at here is, how do you weigh up the complexity and effectiveness of a function versus the intuitiveness and ease of the tuner being able to actually get the result?
First is every time we have an opportunity to not open the PID or open the control, we do. Which means like we work very hard to set up, try, test, and see if it's not necessary to leave it open. We don't even open. Obviously, we usually have an advanced mode where you can open that, but we have predefined levels, or we have, so in the traction control, we have 20 predefined levels, which pretty much adjust the PIDs between something already are tested that will work. And typically the mid-level will work for 70% of the cases. So we have so many features that has all the intelligence in the background, and that makes us more popular because a lot of people, you don't have to really build your own firmware or your own feature. You actually just enable the feature, and the predefined settings will probably let you already run very well, considerably well.
I mean, I think the easier you can make it for the tuner to get a good result, the better the finished product is going to be. And if it works, obviously you end up getting a better name as a result. So that's a win-win. Coming back to the design of the ECU, I mean, from my standpoint, probably the obvious elephant in the room that sticks out with FuelTech is the form factor, in that it is an ECU as well as a dash display, plus a built-in data logger, plus it's touchscreen capable. Is this sort of something that was born out of that original product where you had the simple display and you just sort of developed that further, or the lack of availability of laptops in Brazil? Yeah, I'm interested to sort of see what drove that, because it's quite unique in the industry.
When we started was the lack of really no tuner at that time. They were all carburetor, no data acquisition tuners. So we decided they had to use their hands and not a laptop. So the first unit did not even had a USB or serial cable. It was completely on the screen only. So to save your tune-up, you had to write it on a sheet of paper. That was the way of saving your tune-up at that time. You literally had to do that. So there was no connection to the computer. Then that was 2001, 3. Then in 2008, we actually released the first data logging. Was a standalone data logging with a USB connector that could actually data log 6 channels, and including wideband O2. That was 2007, 8, something like that. Then in 2009, we released the second generation of our ECUs, which was the FT200, and then FT250 or FT300, which still had the display, but has the CAN port to actually have a CAN to USB connector cable that you can actually hook up to the laptop and basically see the same we were doing on the screen on the laptop. Then we added the data logging capacity to that ECU. It was only 30 seconds data log, was very limited, but was enough to start with something. So then we released the FT400, which was a natural evolution from the small screen to a touch screen, and start becoming like a dashboard. But different than just a dashboard, you still could be doing everything on the screen. So that's our essence. Every FuelTech, you can do everything through the screen. So a lot of people think, okay, that's the same as having an ECU and a dashboard. No, that's not the same. You literally can do everything through that screen. Then the FT400 opened up in 2011 our kind of screen capacity, so we could start doing more complex features because there were better screens area to actually even adjust that. But the biggest change was 2013, 14 when we released the FT500. As I was mentioning before, the 500, even having the similar look as the 400, that was a strategy to actually make it more comfortable switch, because if we were about to tell all our clients at that time such of a difference between both products, they would probably be scared. we wanted to do a seamless, a easier transition. So we even kept the same connector in the back, same screen, same size, same bolt pattern, and it was easier for them to do the transition. But the software, the processor was completely different. Everything was different. So the 500 also incorporated the 3D tune-ups, the 3D maps, also a lot more complexity, obviously. And since 2014, when we released the 500, on the 500, when we actually partnered with Proline Racing in 2013 and start testing the product on their dyno, we did a very successful launch of the product by pretty much switching dozens of their cars over the winter and showing up on a race. And it was a big surprise because no one was expecting so many top contenders switching from one ECU to another ECU on the winter. And then we showed up in that race and then in the domestic race and started winning races. And then that was our turning point in the US, because before in 2008 to 2013, I've installed for free hundreds of ECUs. I try to give away. I try to go to shops and try to go by the bottom. It took us a long time to understand we need to go top down instead of from the bottom.
Yeah, I think drag races, I mean, this probably goes for all forms of motorsport, but people are very much going to stick with the status quo and what's known and what's working, rather than take a risk and try and switch to a different system. But, I mean, as we've sort of seen, the FuelTech brand is now sort of synonymous with high-end drag racing and the likes of Sport Compact and Pro Mod. I guess as soon as you start winning a few races, people start taking notice, and then the landslide begins and people start switching systems. Just in terms of the design strategy with getting everything inside of one box, this is something I'm interested in talking about, because my experience with drag racing has been that a lot of competitors have kind of almost gone with a more is better approach, and they'll have an ECU to control the engine, then they'll have maybe a different box that's for boost control, maybe a separate box for ignition control, or a profiler for essentially traction control. I've never really understood that mentality. From my perspective, it seems messy. You've got so much more potential for failure, and there's no or limited interaction between the different modules. They're not talking together. You, on the other hand, have kind of brought everything into one box. So how hard was it to get people's mentality to change and adopt that approach?
So the reason why the industry standard was to have one box per feature was, in my opinion, first, there was one company focusing so hard in trying to accomplish every aspect of the electronics. They were focusing, one was, okay, race pack was data logging, maybe a few issues or fuel and timing control. Then somebody start digging into boost controller very deeply. Then another one on timing control, traction control. So you start having companies focusing on one specific area, and there was almost no solution completely about that. There was also limitation about hardware, in my opinion, processing capacity or software, how to actually accomplish everything in one unit. But at the same time, the technology advanced so much in the last 5 years or 10 years that more than the previous 50 years eventually. So the processing capacity increased so much that it was a turning point where around the mid 2010s, it started becoming available. Even on Motec, I think the M800 series or the 100 series before was not doing everything, but then the M1 came, and then you started having power processing capacity to do more of everything.
So this was a hardware limitation, that the hardware available back then just you couldn't do justice to an all-encompassing full vehicle control strategy.
I believe so. Obviously, you always have a very high-end stuff, but then you go to the next step is like, you have to make something accessible and easy enough to use. If not, they would just go back to the carburetors. You know what I mean? So, and that's where I think we try to do something simpler. We always tried, okay, how can we do the same or better in a simpler way? How can we just simplify their life? Because if you ask, nobody wants to really have more effort. And they always tend to, spend less time doing something. So we try to simplify. I think we were on the FT500. We became one of the first to use the latest processing technology. Was the PowerPC Corriva generation in 2014. I believe we were the first ECU to use that level of processing capacity on that year. And then we learned quickly in 2014 to 16, we released the FT600. So the FT600, at the release, we designed it to be the best hardware possible. Doesn't matter how much it will cost. We literally said, we don't care how much it costs to do the best possible hardware. We want to have unlimited capacity. We want to do everything possible. So then we released the hardware of the 600, which was a very advanced graphics processor. The ECU processor and all the hardware was the best possible hardware, no matter how much it cost. And then we start writing code, software for it. And from 2014, when we released the FT500, to now 2023, over the last, how many years? 9 years, right? For 9 years, we released about 100 big software update packages completely for free on the same hardware we designed in almost 10 years, or more than 10 years ago. So that hardware was designed and lasts for 10 years. And now we're finally maxing out that hardware with software with the FT600. But if you compare the FT600 today, it can literally do anything on the car. It can control any transmission. It does data logging, traction control, wastegate control, boost control, nitro, you name, probably we can do mostly. Then obviously now we're into the next generation with the Vision FT, which is our vision of the future. We use the name. So the FT700 is already 3 years under development. Obviously a couple years were private development because we don't want to share that early in stages. But that 700, we believe it was going to also be capable hardware for the next 10 years of software development.
So is it about a 10-year lifespan you see with what is at the time a current cutting-edge generation of processor that gives you sort of about a 10-year lifespan before you start maxing that out, and you'll need to look at the next generation of whatever's come up in the time being?
Yeah, obviously, statistically, that's true. But it's always like we try to do the best, absolute best possible right now. There's no better technology available right now. We incorporated like every single aspect of technology we could even think of. So we can read 400 kilohertz input channels and process that. We have camera inputs, microphone inputs, audio output. We have GPS. We have Bluetooth, Wi-Fi. The graphics processor is unbelievable. We can process video and turn that into math channels from the video inputs on the ECU. So there is like so many inputs and outputs and specific hardware conditioners like wideband 2 integrated wideband 2 conditioners that reads any kind of 2 sensor. So we did every single aspect of hardware we could think of or could find or be able to do. Obviously, the release we will only have probably be using 15% of that capacity. And then in the next years, we will release updates to actually be able to use all that hardware.
If we talk about an eye to the future, which it sounds like you're obviously very much thinking about, this new generation of product, can you talk to us, obviously, as you mentioned there, as time goes by and there's demand for new functionality, which we don't even know what that might look like now, potentially in another 5 to 10 years' time. But for someone who's an existing FuelTech user, what would be the advantages or benefits in switching to this new platform when it is available for public consumption? So
first, we always take very careful ability of upgrading the product line from the previous ECU line. So if you had, every time we release a new product line, the previous ECU owners or tuners, they had a very easy way of open or loading their tune-ups from the previous ECU generation to the new generation in a seamless way. So it's almost like you buy a new iPhone. You want that to be transparent. You don't want to spend a week setting up your new iPhone. You want to just leave with the new iPhone and that's it. So even the connectors on the back of the 700, there's 5 connectors, A, B, C, D, and multimedia connector. But the A and the B connector are the exact same as the 600 ECU. So right now it's you can actually unplug your FT600 and plug the 700 and load your FT600 tune-up, and you should be running the exact same way you were running before. So that should be one very easy way of upgrading. Then you have more inputs and outputs on the B, and the C, and the D connectors. you have more capacity of adding more sensors or adding more outputs and controlling more stuff. But then the multimedia connector is something interesting because then you can add cameras hardwired to your car, and it can be the $30 camera. You can add a couple microphones, one in the engine bay and another one on the driver's side, let's say. Then you just made your data log, bring in camera and audio. You have one file that pretty much combines everything and make your life so much easier to analyze. So you may have a remote tuner look into your stuff, and instead of you having to explain to him what happened, he has a video and also audio about that. So the same way you use your cell phone, I believe we are closing the gap to the cell phone technology, because our interface is closer than ever to what you are experiencing in your other multimedia devices. And if you really think 10 years ago, I think the ECU industry was way behind on the other electronics technology. So I think we're now getting closer to the latest technology in these areas.
Sure. Yeah, that's interesting. I do really like the way that you've got that reverse or backward compatibility with, so you're not alienating your existing users. That's a really nice function there. Just to change direction a little bit, I just wanted to talk about, we've mentioned the fact that sort of these high-end drag cars have gone from running multiple different controllers and boxes for different aspects to sort of one complete unit. That's not to say that everything is controlled necessarily within the one unit. We've already talked about the external CDI, capacitive discharge ignition control boxes. We didn't actually mention that's an external box, but you do sell these. The other element that I'm interested to dive into and just sort of a reasoning why is your external injector drivers. Typically, these are going to be housed within the ECU, but you've got these auxiliary or external, I should say, drivers. Is this purely as a way of supporting the high injector count demands of some of these drag racing engines, or is there another reason why you've gone that path?
Yeah, basically because we always had the screen incorporated, and specifically our units were mostly plastic cases. We have a heat dissipation limitation. So injector drivers, they will heat up more than a saturated driver. So
we're talking here peak and hold versus saturated drive.
Yes. Yep. So a saturated drivers almost hits nothing. So we can drive 24 injectors, high impedance from the ECU, and the plastic case will not even dissipate anything. So we had a compromise or a decision to be made. And since our core strategy was to incorporate the screen, we're not going to separate the screen from the ECU, which we believe was our differentiation. So, and also you can also name, but probably less than half of the users do really use low impedance injectors.
Yeah, low impedance injectors really are sort of almost a thing of the past, except for some specific applications. And a lot of the very, very high flow fuel injectors that we see in drag racing are still a peak and hold style injector, correct?
Yes, and exactly. But then you limit it. I would estimate a lot less than half of our clients really use low impedance injectors. So the use of injector drivers is actually less relevant, because you only a few clients. Then there is another aspect, the drivers being external. I would say the two most trusted electronics on a car are the ignition boxes, number one for sure, and the second one are the injector drivers. So those are the two most prone to failure electronics on a racing car. So to have them externally, you don't really, let's say, you don't break your ECU if anything goes wrong. We understood that also from the market, that they wanted something external that could be easily diagnostic or replaced on the fly. So technically, that was also seen as a benefit by some people.
I'm interested just with the external injector drive box. How is that communicated to by the ECU? Is this CAN based or is it a hardwired?
No, the CAN bus is only for diagnostics, because CAN is not anything critical, and timing cannot be through CAN bus, because CAN bus is not confirmed. It doesn't have a timing system confirmed. It's about load and availability of the bus.
Okay.
So pretty much the external drivers are pretty much inline drivers. So even our injector drivers, a lot of clients, they even install them on OEM ECUs that were designed originally for high impedance injectors when they switch to low impedance, because it's pretty much a dumb box that gets a signal, low side input, and just mimic the output with current control.
Okay. All right. Just diving into the software for a little bit. We talked earlier about the original setup where you had your 2D map for load and then another 2D map for RPM. And at least what I've seen so far, you've retained that ability. I think it's by default even in the ECU we've got for testing at the workshop. But you've then given the ability to also switch to full 3D control. I'm interested, in terms of those two options, what percentage of users are using the 2D versus the 3D?
Obviously, I would guess right now in US market or international market, I will guess 90% use the 3D and 10% use the 2D. But if you go to the Brazilian market, because they're so comfortable with that, I'll guess maybe half. It's like 50%.
So it's basically what you're more familiar with. I mean, I guess anyone or 99% of tuners transitioning from a different platform onto FuelTech would feel more comfortable. I certainly did, using the 3D mapping functionality versus 2D. It's quite a different mindset, I believe, to approach that. The other element, which I think is probably, I wouldn't say unique, but definitely is a little unusual in current terms, is the fact that you've gone with an injection time-based fuel model versus volumetric efficiency. And for those who sort of aren't familiar with those terms, with an injection time-based fuel model, essentially our fuel table, be it 2D or 3D, is directly asking for an injection on time or how long the injector will be open for. And we've got compensations on the background of that. Versus volumetric efficiency, we don't really have a fuel table. Instead, we have an efficiency table. For all intents and purposes, we're telling the ECU what mass of air is entering the engine at any particular combination of load and RPM. So I've seen a lot of ECUs transition to VE based. I think it became almost a bit of a marketing ploy at some point, but there are some distinct advantages with that, particularly when we start looking at flex fuel. I'm interested, did you look at VE based? What was the reasoning behind sticking to injection time?
We didn't even look at the VE based, because remember, that was 20 years ago. We had no reference ECU. For many years, we didn't even knew what was VE. We kind of created our own way of doing that and being advancing that. Obviously, lately, a lot of people asking for the VE, and as you mentioned, there is a transition. I believe some of the higher end tuners or whoever, if you're experienced with that. So our new platform, the 700 and the subsequent products, will have both options on that.
I think probably I would argue that for a novice tuner coming into setting up a fuel table, maybe for the first time, injection time-based fuel models are maybe not quite so intuitive. And what I mean is, you've got a set of 1000cc injectors or whatever they may be. Unless you've had a lot of experience on a given engine with a given injector size, you're not necessarily going to know how many milliseconds the injector should be open for at idle or cruise, for example, versus VE-based fuel models. As long as you input your fuel characteristics, your injector characteristics, and your engine capacity correctly, we could literally set that entire VE table to a value of, let's say, 50%, and it won't be right, but the engine will most likely start and run, and then you can start dialing in your injection VE table to suit. Do you agree with that sort of take on things?
I absolutely agree. But at the same time, we try to compensate our strategy, let's say this way, our way of doing that by, if you look our table right now, I mean, the current FuelTech, you can hit the F6 key, and then the milliseconds will turn into pounds per hour or cc per minute, or they will turn into duty cycle, or we even have a specific, we call percentage of related VE, which is almost like a similar table to a VE. So you can so right now, for example, when I'm tuning, I have in my head, I will use an example on ethanol, 1 pound per hour is 1 horsepower. So for me, it's easy for me to think, okay, this engine in naturally aspirated is like 200 horsepower. If with 1 barrel, like 14 pounds of boost, it's going to make 400 horsepower. So I know I need 400 pounds of fuel on that. So basically my main fuel table is basically pounds per hour. because that's how pretty much I personally think of. But obviously, we're expanding into tuners that did not learn our way or this way, and they come from other school, let's say this way. And I think you're a perfect example, because in your mind is the opposite. You think on VE, and for you it's easier. So, but at the same time, instead of trying to convince you the other way is better, we're offering both options, and that's likely the best solution, because you don't have. There's no absolute true on any of those.
Yeah, I think you're spot on there. It's not like one technique is better or more right than the other, and you're exactly right there with the fact that you've got tuners that think in one way or are used to working in one way versus the other. So I think accommodating for both makes a lot of sense. I mean, I will say that I probably did actually grow up and cut my teeth tuning on injection time-based models, but even then, there's a couple of different ways you can go about that. Because I come from New Zealand and Link is a local producer here, in my early days, I did a lot of Link-based ECUs, and I was also dealing with Motec M4, M48, and then into the 100 series. And both of those platforms used the same technique. They were injection time-based, but they did it a slightly different way. Rather than your fuel table being an injection millisecond pulse width, basically it was represented as a percentage of another parameter, which was your master injector pulse width. I kind of liked that system, and I mean, it came from familiarity. That's what I was dealing with, so I got used to it. But it was a fairly easy system to work with. So that's a subtle difference between that style versus a fuel table, which is literally just injector millisecond pulse width. So sounds like you're going to be dealing with both anyway, so that's going to probably make it easier for VE-based tuners to transition onto the FuelTech platform, I would think.
Yeah, and we're working as well on a ways of actually converting from one to the other and back, so it makes everyone comfortable. Like, we're very excited how that is actually coming out, because it will be a lot of people don't quietly understand one, or let's say they are more familiar with one, but seeing both ways, they may be even more comfortable about learning that.
Yeah. All right, Anderson, I think we should start moving towards wrapping this up. I want to respect your time, and I think we could probably spend another couple of hours on these topics alone, but we'll keep it as brief as we have. We like to finish our podcast with the same three questions we ask all of our guests. First of those questions is, what's next in the future for you and FuelTech? You've already kind of given us a little bit of insight into your new platform, but what else is in the pipeline? What do you want to expand on?
So now we created the platform that will allow us to be crazy on software, crazy on creations. So we all know AI is going to impact everything in this world. We know there's like video integration. We know like everything, like crazy levels of integration of stuff. So I'm so excited about how much we can actually incorporate and implement. That's probably going to be very exciting for the next few years. Obviously, the electrification is something we're very excited. Even our current platform, the FT 550 and 600, we're releasing a software update that will incorporate all the EV controls into the same ECU. And that's going out in June right now. I mean, we already have like a lot running with that. I'm excited about that as well. And honestly, everything that brings to technology to performance is something that excites us.
Definitely. I'm interested in terms of the AI element. Yeah, I mean, we've sort of seen with the likes of Chat GPT and Midjourney, etc. We're starting to maybe see a glimpse of the potential that AI is going to bring, and I think we're only scratching the surface right now. I'm interested if you could maybe give us an example of how you see AI being integrated into the standalone ECU world.
Imagine if you train AI into, like, I want to build a tune-up for a car. These are the characteristics. Or you can even do like, once the self-tuning or self-adjustments will be in a completely new level with AI. But then you have to have processing capacity in the ECU, and that's where we're preparing for that. So I don't know exactly how it will play.
Watch this space.
Yeah, we're preparing for that.
Okay. Next question, Anderson. Is there any advice you'd give to a younger version of yourself to help you reach where you have today in your career faster?
Yeah, I think don't try to copy whoever you feel is successful and you want to do the same. That's probably not the best strategy. But at the same time, believe in your dreams. And if you have something that you believe is different, then solve a problem and don't let people let you put you down in terms of changing your mind just because they don't understand it yet. So I mean, try to solve a problem, try to help solution of something is more relevant than just chasing something that seems to be a good business.
Yeah, yeah. I think that's probably pretty reasonable advice. And I think the not trying to sort of create a copy of a competitor is definitely really important to keep in mind. There's levels to this. Obviously, if you're just going to copy someone's product, you're going to probably come out with a second-rate version of their product and be behind in their marketing. At the same time, I think there's an element here where we do need to be aware of what other competitors are in our marketplace and not necessarily trying to copy them, but also just monitoring maybe would be a better way of putting it, what direction they're taking with development so that you don't end up finding that you've got left behind by a couple of years and got to play catch up, because that can happen too, I think. I see this in the ECU world, where I probably liken this to the software element, because I am probably reasonably unique in that I do consistently work on a variety of different brands. I'm always sort of saying, this brand does a really great job of this particular feature, but then brand X over here does an amazing job of this other feature. And, if we could just bring all of that together in one sort of perfect product, it'd be amazing. But then I guess the other element with that is that my expectations and what I want out of an aftermarket ECU probably aren't also the norm either. So there's a balance that goes into that, I think.
Yeah, great point.
Last question for today, Anderson. If people want to follow you and see what you're up to, find out about the FuelTech brand and product, where are they best to do that?
Yeah, so I have a YouTube channel, a personal YouTube channel, is mostly in Portuguese, is Anderson Dick, but I do have English and Spanish subtitles all the time. So I share a lot of my personal projects and a lot of even our company projects. Also on Instagram as well, same Anderson Dick. But obviously our FuelTech USA and FuelTech, the Brazilian Instagram and Facebook and YouTube channels are something we invite you guys to come and watch.
We'll drop links to those accounts into the show notes just to make it real easy for people to find you. Look, it's been a great chat, Anderson. Great to get some insight, and particularly enjoyed that deep dive on methanol fuels, lambda targets, ignition systems. That got really deep really quickly, but we appreciate you sharing your experience there. Thanks again for coming on the show, and we wish you all the best for the future.
No, and I do appreciate the invite, and it's a pleasure to talk to you guys, and obviously I appreciate all the thanks for the audience as well. We're very excited to be making some progress, some difference in this industry, in this world.
Absolutely. If you enjoyed this episode of Tuned In with Anderson, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Mattman94 from the USA, who has said, great info and interviews. I learn something new with every interview and walk away with something to look up, to read and watch even more about. Great interviewer with lots of well-informed questions. Well, thanks for your kind words there, Mattman. And if you get in touch with your t-shirt size and shipping details, we'll fire a fresh tee off straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention, for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.